My name is Andrea Aime. I work for GeoSolution, an international company with offices based in Italy and the United States. We offer support and development on a number of open source projects as core developer participants in each of these projects. As a company, we believe in open source, in open standards, and that's the reason why we participate in this conference. Okay, so this talk is about styling natural earth with the GeoServer GeoCSS language, for which I already gave a workshop a couple of days ago. So first of all, what is natural earth? Natural earth is a public domain map dataset that you can find at naturalearth.org. It features tightly integrated vector and raster data. It's actually mostly vector, but it contains a few raster backgrounds as well. It contains three datasets, one to 110 million, one to 1 to 50 million, and one to 10 million. Some layers do repeat across the three generalization levels. Others are specific to just the most accurate datasets. So, for example, roads you can only find at 1 to 10 million, while countries, for example, you will find at all zoom levels. The dataset can be downloaded conveniently using a zip file or a geo package, but you can also follow links on each and every of these three datasets and download individual shapefiles for each and every layer of your interest. This is just one example that I took from the 1 to 10 million page, but as I said, there is a lot of datasets, and they keep on being updated periodically as well the data that they represent changes or as fixes are needed in the data itself. GeoServer CSS is a CSS-inspired language for map styling that you can find as a plugin in GeoServer. It's compact, powerful, human-readable, and human-writable. Especially the human-writable part was the reason why it got developed, as, well, writing and reading SLD is not exactly a joyful experience. Let's put it this way. So, as the language, it's based on the same concepts as a CSS for the web. You start with a selector. In that case, a star means match everything. So it's going to match every feature at every zoom level. And then inside you got properties. The properties are not talking about attributes of elements, divs, spans, lists, and so on. They talk about properties meaningful for cartography, such as stroke and fill and label. You have conveniences common to the CSS, like named color. I can just say that the stroke is blue. You have the ability to use attributes through expressions. When you want to use an expression, it's between square brackets. So in that case, the label is referring to the name attribute. That's just a very simple example. Any SQL expression would fit inside the square brackets. So if you want to start calling functions to concatenate strings, uppercase, lowercase, or in case of numeric properties like the width of a line, you could do math on top of it, or the rotation, you could do math on top of it, and so on. Maybe you have two attributes which are the projection of the wind vector on the two axes. You start doing sine and cosine to get to the magnitude and direction, for example. You can do stuff like that. So it's pretty powerful. And well, in the end, it translates down to SLD. So GeoServer actually renders the translated SLD. Because the rendering engine really talks SLD, not CSS. This is true for every alternative language that we have in GeoServer. They all translate down to SLD eventually, and then the rendering engine processes the SLD. Now, why have I worked on styling natural earth? When GeoSolutions shared a few years ago OSM styles, a repository that you can find in our organization that contains CSS styles for OpenStreetMap. Well, it's because I needed something that was teachable in a few hours and not a monster that would require a week of explaining and that would be just too much. This is an example. OSM styles is nice, it's comprehensive, and it's used at geoserver.org in the little map that you can find on the homepage. I centered it on Prizren. But the problem is, if we just have a look at the road.css style, which is one of the most complicated, and I picked it on purpose, you can see it's 1,300 lines of CSS, which, well, defeats the purpose of trying to explain it in a teaching session. It's just too much. It's too complicated. I wanted something simpler, yet interesting. So I set up for a simpler map. I decided to do Natural Earth because it's another simple dataset that it's easy to download. I wanted to have simple yet interesting styles, so a page full of CSS, not more. I didn't want to have hundreds of lines of CSS in the styles, but stuff that was much more compact. And for the inspiration, I took the printed maps that I found in the atlases when I was a kid, when, you know, GIS was not a thing. And instead at school, you were opening these atlases with political maps and all sorts of maps, like the one displayed here. So, the political map. This is a few screenshots of the political map that has been generated. Whole world, focusing on Europe, and as you can see, as we zoom in, more and more detail pops up in the map. So, for example, here we only have capitals and world cities. At this zoom level, we start seeing more and more cities. As I zoom in more, I see urban areas, ferry trails, roads, and borders, and so on. So the number of information included in a map goes up as I zoom in, which is, by the way, the norm. And this is yet another zoom level where I can appreciate more both the borders and the urban areas. Now, all of this is powered by a layer group that contains a stacking of all the various datasets available at 110 million, 50 million, and 10 million. Of course, with the right scale denominator controls in the styles, so that they activate and deactivate as we cross certain scale denominator thresholds. So in this case, at 70 million, we switch from the 110 million dataset to the 50 million dataset. And then at 20 million, we switch from the 50 million dataset to the 10 million dataset. Okay, first example of a style, simple yet interesting, oceans. You can see that there is a scale dependency at the top. When the scale denominator is greater than 70 million, then fill. How? Superimposing two symbols. In CSS, when you want to superimpose two symbols, you specify the first symbol, and then a comma, and then the second symbol. So in this case, the first fill is a solid color, light blue, but it turned out it was still a little too dark, so there is a function in GeoTools that you can even use in SLD if you want, which is called lighten, and you provide a percentage. So it's a nice thing to have, in my opinion, because you typically have a feeling that you got more or less the right color, but you would like to have it slightly darker, slightly lighter, or more colorful or less colorful. So there are these manipulation functions which are being stolen from LessCSS, if I remember correctly, that allow to take a starting color and just tweak it. The other symbol, it's a shape column / which is a diagonal line. It's really just a diagonal segment, but when you start repeating it over and over and over, it generates a hatch fill. And the second part is a pseudo selector, column fill, to control what goes on inside the slash. In particular, we control its sides. You make it bigger, you have a coarser hatch fill. You make it smaller, you have a denser hatch fill. There you control the stroke, and again I started from light blue and I made it lighter but not so as much as the background, and then the stroke width. And we get this result of a pattern over the sea. Why did I want to make a pattern? Because the tone of blue that was chosen for the seas was starting to become a little too close to the colors used for the countries, and I needed to make it stand out so that the countries and the sea would not blend together visually. And instead of using a completely different color, I changed another visual variable, which is the shape, that is the contents of the fill, the hatching. And that's enough to tell apart quite clearly the sea and the land, even if the colors are similar. Another example which is interesting in this little styling dataset is the usage of an external tool, in particular the color brewer. So this is for the countries. The countries need to be depicted with some colors so that two neighboring countries never use the same color. The natural earth dataset already has an attribute called map color 7, if I remember correctly. It has 7 numbers inside. If you associate a color to each number, two neighboring countries will never share the same color. They basically make sure that two neighboring countries never share the same number in map color 7. Now, Color Brewer is a very good tool that you can find on the internet. It's a website to create a color palette. And you start telling it, well, okay, I want a color palette with 7 classes. And then you decide which type of classification you want to make, a sequential, a diverging, or a qualitative. In this case, it's a qualitative because we are not talking about a scale between low and high or bad and good, but it's just 7 different things. I picked up a color scheme. I wanted pastel color, very, very light. So I chose the one in between. And then you can also play, if you have the need to do so, with only displaying colorblind safe combination or print-friendly combination or photocopy-friendly combinations and so on. For this one, I settled down for a generic palette that works well on the web. I didn't care too much about printing or photocopying, and I didn't care also about color blindness, although if this was not a training map, but a real map, you would have to think about it. And so, the Color Brewer comes out with these 7 colors here, with hexadecimal values for each one. And they are turned into a CSS equivalent using the recode function. The recode function takes map color 7 and then starts doing the association. Take 1, turn it into one color. Take 2, turn it into another color. I set it up and then found out that a couple of colors were still a bit too dark, in my opinion, in the overall economy, let's say, of the map. And so I, again, tweaked them a little bit to make them a little bit lighter using the lighten function. Since we are talking about countries, here is an example of labeling with CSS. Again, it's picking the attribute called name, centering the label. I started with a black label, which I thought was going to provide good contrast with the light pastel color of the fill. And then I found out it was too much contrast. It was too stark. So again, I lightened it a little bit to reduce the amount of contrast between label and background fill. There is a halo around, and also interestingly, that label dash priority, which links the priority of the label with the number of people inside the country. Why? This is a multiscale map. When we zoom out, we are not able to label all the countries. That's not possible. It would be too many labels overlapping each other. So we have to make a choice. The priority makes sure that the countries with the most people inside are displayed first, and the others pop up as we zoom in. Of course, it's how to put it, arbitrary choice. I could have used the GDP of the country or the alphabetical ordering of the name of the country, whatever. This one seemed to make sense. One thing that is important is that we always get the same order every time we display the map. At the very least that. And then we can see that there is some auto-wrapping at 100 pixels to wrap around long labels. In this case, we have an example there with the Bosnia and Herzegovina. And, well, there are a lot of long names in Africa as well that needs this auto-wrapping. Here is another example. We are still looking at countries, but we have in the overlay states and provinces. States and provinces are kind of a strange thing because when we start with a 110 million dataset, the only thing that they contain is the states of the United States, because it's a primary subdivision, but it's a big one that you can still see at 110 millions. And then as you zoom in, more and more countries join this splitting into parts game. And at the 50 million dataset level, we have the splitting, for example, of Brazil, but we also have it for China and we also have it for Russia. Eventually, the other countries like Italy that have small provinces join the game in the 1 to 10 million case. The slide is called pen up, pen down, because that's how we achieve the dashed line that is the border between the provinces. So here the idea is that we have this stroke dash array property that says 4, it means pen down 4, write a line, pen up 4, skip, pen down 4, pen up, and so on. So with 4 you achieve a relatively dense dash over the line. You make longer numbers, you get a coarser one, and you can start doing stuff like, I don't know, line and point by doing 16, 2, 1, 2, and then repeat, and then you have a line, a little space, a point, a little space, and then you repeat, and you get out a point and line pattern for the line. Another interesting thing about choices made in this style is the label -fit -goodness property. This property, which is normally called the goodness of fit, is the relationship between the size of the label and the size of the polygon that it's labeling. We don't want the label to be too big compared to the polygon, otherwise it would just hide away the polygon. So the idea is that normally GeoServer would display a label only if it fits at the very least 50% inside the polygon. That's the default value for that property. In this case, we pumped it up to 0.8, so 80%. So most of the label is actually inside the polygon. Why? To avoid overcrowding the map. So it's a measure to reduce the number of labels in the map in this case, because otherwise I would have gotten too many, especially as I zoom out a little bit. Getting the right blend. This is another simple yet interesting trick. So we have urban areas, and at the beginning I said, okay, they don't have any attribute. I just wanted to display their presence. They are urban areas, so I'm going to use a gray because it reminds me of cement. And then I looked at the map, and if you look at Italy and Germany, I don't know if it's visible, not too much, but over Italy, the urban areas are in too stark a contrast with the background. Over Germany, they are barely visible. Why? Because Italy is pale yellow and Germany is a bluish color, which is darker. So I don't have the right amount of contrast. It works well on some colors, it doesn't work well on other colors. So what do we do? Well, there is a trick which is called color compositing, which is available in GeoServer, in which you take the background color and you multiply it by the color of the overlay. And it's achieved via that composite multiply mode. There are various modes to test. Multiply is probably the most commonly used because it blends the color of the background and the color of the foreground in a way that is not as dull as pure transparency. The first thing that you could do would be to just make the color 50% transparent. It sort of works, but the result is a little bit dull. In this case, instead, it offers the right amount of contrast, more or less, regardless of the color of the background. And indeed, you cannot see much in that, but I think you can see the urban areas in the map below. If you go look into the documentation of GeoServer, there are many other examples. Another example, which is, in my opinion, interesting, is adapting continuously the size of strokes and labels and so on as you change the zoom level. If you look at OpenStreetMap styles, it's controlling that by many, many rules and saying something like, oh, if the scale denominator is this, use that size. If the scale denominator use another size. It's a table. it's annoying, it's long, it's super detailed. And instead, with this interpolate function, we interpolate on the scale denominator property of the current scale, and we say, well, okay, I want 2 pixels at 2 million, 0.1 pixels at 10 million, and that's it. Figure out the rest by yourself. And so it linearly interpolates between the two extremes. And it has been done for the stroke width of the provinces subdivision. You can see the dash pattern getting thicker. And it does the same with the labels, with the font size of the labels. Roads. Well, roads are never an easy use case. In this case, we have many nested rule controlling the various classes of roads. So we have ferry type, which are actually not roads, but ferry routes on the sea, which are displayed with a dash array. And the roads are classified by their category, primary, secondary, and so on. And you can see the trick of using the Z-index to get proper coloring of the highways, which are typically displayed as thick line and thin line over it. If we weren't using the Z-index trick, we would get interruptions at the intersections. And instead, with painting all the thick lines in one shot and then painting all the thin lines in a second pass, we get a seamless connection at the intersections. We also have an interesting We also have an interesting bit in the labeling. Labeling highways typically means creating road plates below the label of the highway. In this case, it's a simple symbol, a square, that is being then stretched using the shield resides policy to match the sides of the label. So we start with a square and we stretch it to fill the sides of the label. We add a little bit of margin, 2 pixels, and control the coloring of it using the column shield pseudo property. Now, what about a physical map? A physical map is in progress. I started working on it. A physical map is basically a drop raster that you use mostly at all zoom levels, and then adapting all the labels to identify the various physical elements in the map. Seas, continents, mountain ranges, and so on and so on. It's available as a branch in the AnyStyles repository, and it's not yet finished. If anyone is interested in participating, I would gladly receive pull requests. Okay, how can you get this? Everything is on GitHub in our repository, and as you can see, the physical map is in a branch of the same repository. And we are open in terms of tickets, in terms of pull requests. Please participate. And that's it.